we're thinking about this curriculum in terms of what we're covering and why it's important, how they're all related together, and then we'll jump into the section on HTML. So to start off, what is programming? Kind of an esoteric question, but essentially, from the outside looking in, programming can seem like it encompasses a lot, but really at the end of the day, all programmers, software developers, we're going to call them, all we're really doing is problem solving, right? All we're really doing is just saying, okay, I have this problem. How can I use technology or how can I use computers more specifically to solve it in a more efficient manner? What kind of problems do computers solve? Generally speaking, computers are very, very great at solving highly logical, highly precise problems, right? So if we think about something like adding numbers or multiplying numbers or any kind of math related things, computers are phenomenal at that. Why? Because there's only one right answer, it's reproducible, and because computers can do it so fast and so much more accurately, they can just perform these functions so much better than any human being can ever hope to, right? And generally speaking, when we talk about the types of programs that, or the types of problems that computers, that software usually solves, it comes down to this idea that if I give a computer some bits of information, it's going to do something with that, and it's going to give me back what I need, as in the answer or the response or a program or an answer or something along those lines. So that's what we mean when we say that programming is really concerned primarily with transforming input, so information that we give it, into output, something that's able to kind of give back to us. Now, because programming is highly logical and decision making, note that when you're looking at code, a lot of times one of the best ways to troubleshoot problems is actually put yourself in the shoes of the computer and think, if I was a computer and executing this code, how would I logically do this? We'll talk about pseudocode. We'll talk about some other concepts later on that kind of drives this point home a little bit further in. But for now, just keep in mind that computers are very good at solving logical problems. But what that also means is that they're actually also really bad at solving ambiguous problems. So what do I mean when I say ambiguous problems? If someone asks you a question and you don't know what the answer is, one response you might give is just Google it, right? And to us humans, it sounds like a very normal thing to say, right? But if you think about what just Google it means to a human, it means go to a computer, open up Chrome or Firefox or your browser of choice, go to google.com, type in your answer, look at the answer, and interpret it, right? And just from those 3 words, you can see how that fleshes out into like 6 or 7 things that you need to do. And so for computers, they're actually very bad at handling ambiguity. Why is that important? Because when we're writing code, one of the things we need to make sure that we're kind of hypersensitive or aware of it at all times is, are we giving the computer the exact precise directions that they need or it needs to be able to carry out the function that you wanted to carry out? Very often when people first start off, they say, well, I want the computer to do this, so I just asked it to do it, and I just kind of assumed it would figure it out. And that's usually a very bad place to start, because computers, for the most part, can't really figure it out, right? They're not designed to figure things out. They're designed to execute things precisely the way that you've told them to, or the way that you've written the code. Because computers are so precise and so fast, they're obviously great for jobs that require a lot of repetition, right? So once again, we go back to the math example. If you think about how, something like Microsoft Excel crunches numbers, right? Much more better and efficient than any human ever could be. And then lastly, when it comes to being a social activity, there's this stigma that all programmers are just people who are locked up in a room somewhere, kind of by themselves with no lighting, chugging Red Bulls and just hacking into the wee hours of the morning. But the reality is, the vast majority of software programming takes place on teams, right? If you just think about the wealth of software that's been built over the past few years, even nothing that's really big or really powerful, really meaningful, can be accomplished by an individual, right? You may have very smart people leading the charge. You may have people kind of coming up with innovations and ideas and working through things. But you take any app, like even for example, let's take Facebook as the example, right? Like not only can a single person never build Facebook by themselves, a single person probably can't even build any Facebook feature by themselves, because it's such a complex, such a heavy task. And so because of that, core of programming is actually being able to work on teams, be able to collaborate with other people to kind of bring together these massive projects that hopefully can make a meaningful impact on the world. So part of what we also want to teach you in this class is not just it's not just like memorizing technical concepts. It's also being able to articulate and communicate those technical concepts to other people, especially the people that you're working with. And then last but not least, programming is very creative. One of the things that people like to ask when they're first starting off is, hey, is this right? And yes, like I can tell you when something's wrong, most likely is because it's not doing the thing you want it to do. But as with any idea, there's multiple ways to do the right thing. If I say, hey, can you just add up these numbers for me? Well, we can write plenty of variations of programs that do that. And so at some point, it becomes less even of a what's right and what's wrong, but a matter of what you prefer. Does this make sense? Does it work? And then we want to get more advanced. Is this the most efficient way to do a given problem? But just know that programming is supposed to be creative. It's supposed to be able to allow you to, take risks and kind of create a solution to a problem the way that you think about it. And very often when we actually compare different programmers who work on similar projects, you'll see that they approach it very differently, and that's a reflection of personality as well as ability. So for this class, we're going to be talking about three things primarily: HTML, CSS, and JavaScript. The reason why we chose this is because these are the three front-end languages that kind of most quickly allows you to build your own web page. So HTML stands for that thing that you will never need to know ever again. But really what HTML allows you to do is it allows you to create the components or the basic pieces of any web page that you've ever seen. So if you think about going to ESPN or CNN or whatever your website of choice is, right? Everything on that page, whether from the text to the images to the logo to the input boxes to the links, those are all components, what we call elements of a web page. And HTML allows you to create those elements. Now, one of the things to be very well aware of is that when I go to let's say CNN, right? If I go to that website and I say, hey, can I go to CNN.com? CNN.com doesn't give me back a photo of their homepage and say, can you show the user this? What it actually does is I actually make the request through my browser. We'll say Chrome. I make the request through Chrome, and then CNN actually gives back Chrome a packet or just a bunch of information, but it's not stored as an image. It's actually stored as HTML. And so it's actually up to my browser to interpret that HTML, take it, and translate it into the web pages that we're more accustomed to. And so HTML really underlies the basics of web pages. And because of that, one analogy that we always kind of talk about here is HTML is basically the skeleton for your web page. They really allows you to create the base, bones, and the components of your web page in a way that not much else can, really. And so if HTML is like the bones, like the skeleton, the bare basics of your website, then CSS becomes the skin, right? The clothes. Basically all the things that make your website or your web page pretty. So this could be like colors, fonts, backgrounds, other customizations you might want to do with images and visuals. You can do a ton with CSS, but essentially all CSS, like not all, but the main goal of CSS really is to prettify everything, is to make everything look pretty, make everything look aesthetically pleasing. And we'll be talking about tomorrow. And then last but not least is JavaScript. So if HTML is a skeleton and CSS is a skin, then the JavaScript we can think of it as like the nervous system or the brain of the web page. This basically allows you to take action. Action could be a lot of things. Action could be saying, hey, I want to request more information from other web pages. Action could be, I want to click on this button, I want to have the entire screen move around. Action could be, I'm trying to fill a form on this page. Action could be, I want to submit this form and get back a response. Basically, almost anything interactive that you need to do on the web page is more likely than not powered by JavaScript. And so between all three of these components here, between HTML, which is a skeleton, we have CSS, which is the skin, and then we have JavaScript, which is the brain. Our goal is to kind of teach you all three together in as introductory but as meaningful way as possible, so that when you see a given web page, you kind of have some more sense of how the pieces fit together. Okay, So once again, today's going to be HTML. Tomorrow will be CSS, and then the next 3 days after that will be JavaScript, with the final project on the very last day. Any questions so far? Are we good? Awesome. All right, cool. So let's move on to HTML then. The skeleton. Yep. Okay. Yep. So once again, today we'll be talking about HTML. We want to be able to kind of have you write HTML as soon as possible. You'll learn the proper syntax for writing basic blocks of HTML. We'll go over some basic element types, or some basic element types. But just know that there's dozens, if not hundreds, of HTML HTML element types, and so we're not even come close to covering all of them. We'll just give you the basics, and once again, the goal is for you to know enough to be dangerous and to know kind of how things are formed. But this is not a memorization class. We'll also teach you kind of about how to add additional information to elements, and then last but not least, how to configure them to create more advanced, not advanced, but at least more powerful functionality, like be able to link from one page to another, or showing images on the page. Okay, so on the left-hand side is, and you don't need to bother reading this text because it's all placeholder, but on the left hand of this is this kind of pretty image visual that more or less mimics probably the types of websites that you and I are used to seeing on a daily basis, right? Everything's very clearly labeled. It's all colorful. There's images. It's very clear where I should be reading and what order I should be reading things. This is what a website looks like. But like I said earlier, if I want to know how to create this website, this is probably more similar to the code that I will be working with initially, right? If you notice, there's colors at least, but they're not intentional at least. There's no images, right? There's no spacing. We'll talk a lot more about spacing later on today. Notice how it's just all text. And that's pretty much what HTML is, right? It's all code, it's all text. It's all a way for us to create something that's going to be translated or represents the website. Think of the right-hand side, so the HTML as a blueprint for the house, and then the website itself as a house itself, right? You might look at a blueprint for a house and say, "What is this thing? Like, I have no idea what this looks like in real life. It makes no sense." But then when you see the house, you might say, "Oh yeah, this is a really nice looking house." Same ideas here. So the goal for us today is really just for you to understand the code on the right hand side and understand what kind of understand like how we get to create those components. So all of HTML is essentially powered by what we call elements, and every element is made by for the most part pairs of tags. We'll talk about a few exceptions later on. So what is a tag? A tag is basically one of those two things that you see there. And in HTML, you can always tell what a tag is because it'll be surrounded by these open and closed carets, right? Like the greater than or less than or signs. Each caret is a tag, and most elements are created by a pair of tags. The opening tag, which denotes where the element starts, and the closing tag, which denotes where the element ends. And so the text in between the open and the closing tags are almost always the exact same. The only difference is the closing tag, there's also this backslash, right? And so that tells us, hey, this is the opening P tag, and then when I move on, this is the opening close tag. The name of a tag is very simple. It's just whatever text is inside of the tag. And so here we call this a P tag. P stands for paragraph, and usually this is a tag that we use when we want to write pieces of text. Also, is someone's mic on? I started hearing some background noise recently. And I can check to see who that is really quick. If you don't mind just muting it. Zendeha. Can you hear me? Zendeha? Yeah. Okay, cool. No problem. Just want to make sure. Yeah. So the P tag here then is just So this is a P tag. and this is the element. And then when we talk about multiple tags in HTML, we just basically mean, hey, like literally there are multiple tags, right? The tag looks the same. It's still an open caret and a closed caret. The only difference now is what goes in between. And what goes in between has formatting consequences in terms of telling the computer, hey, I want you to show this element this way. Okay, and so what H stands for is header. And so in your reading later, you'll come across there's basically 6 types of headers in JavaScript. H1 is the biggest header, and then each header gets smaller and smaller all the way until you get to H6. And then after that, if you want it even smaller, you might as well just use a p tag to represent text. And so if on the left hand side, if I want to write a p tag, and in between the 2 tags, I put in the content that I want to kind of be a part of that tag, right? So on the first line here, I have a p tag, and I just want to print out hi. So I just put the characters hi in between there. And then for the h1 tag, I also want to say hi, so I also just put the characters hi in between there. The difference, however, is if you look on the right hand side, that's how it's going to get rendered on the page, right? The p is just plain text. It's very small, so it looks like a small hi. And then on the h1 is the biggest header we have, and so when I put hi in there, it shows up as a very large, very bolded representation. And then we also have something called so this is an image tag. It's unique, and I'll talk about why it's unique near the very end of class. But just notice that this is an example of a unique set of tags called self-closing tags, in which it's not a pair tag, it's just one tag. So if you look at it, we have our open caret and our closed caret still. It's called img, so this is an image tag. And notice how at the very end, rather than having another separate closing tag, we just have the backslash, and the tag closes right away. So this is unique behavior, and the reason for these types of tags is usually because these tags, they don't require things in the middle. And so what I mean by that, if I have a paragraph tag that I'm trying to show text in, well, I need to kind of give it text to show, right? In this case, an image tag just shows a picture or an image, and all we need to do is tell it where the image is. We don't need to feed it any other information, so that's why it's a self-closing tag. But yeah, anything you see in JavaScript is just going to be a bunch of tags arranged or collected or kind of coordinated in a certain way to show the different kind of the layout that we want, right? And notice here, we've already seen 2 ways, and then we'll see a lot more. We've already seen 2 ways of showing text, and we've already seen 1 way of showing images, right? And if you think about most web pages, it's pretty much just text and images, right? So you can kind of already see how we don't need to know that much about HTML to at least be able to start building the very core blocks of a typical website. Any questions so far? Everyone good? I'll wait a few more seconds in case anyone's still trying to catch their thoughts. Oh, yeah. Also, if you have a question, chat is okay, but if you just like yell at me, that'd be even better. The reason why is because when I'm on Zoom and I'm in presentation mode, sometimes I can't see the chat window button flashing, and so I might go for a while without actually seeing your question. So feel free to just interrupt me and cut me off with any questions you may have. Yep. So Katie asked, "What does SRC mean?" And the answer is it means source. We'll talk more about this in a little bit about what source means when we talk about attributes. But yeah, this means source. But once again, we'll cover that later on. We just want to show you this to help you be aware of 2 things. One is that you can pass additional information to tags, and then 2 is that not all tags have a separate closing tag. Some just have 1 tag. Okay, so if us having p tags and h1 tags and image tags allow us to be able to create text and images, then the next question becomes, okay, well, how do I start thinking about their relationship to each other, right? How do I think about arranging them? And that's where this idea of parent and child elements comes into play. What do we mean when we say parent and child elements? If you think about the way that we, for example, the way that we make lists, which is an HTML element, not all elements are kind of equal, right? And so the UL tag is a common one that you'll see. And what UL stands for is unordered list. So basically, if I want to make a list with bullet points as opposed to numbers, how do I make that list? Well, an unordered list would be a great way for us to do it, right? But one distinction I want to make is that if I make an unordered list element, every item in that list now more or less belongs to that unordered list kind of container, right? Or that kind of package. In this case, in programming, we like to kind of adopt programming to very family-like analogs. And so when I have a container for a unordered list, we basically call that the parent, right? As in this is a parent, and all the elements inside of it, in this case, each individual list item becomes the child. And if we take this one step further, then all the childs are siblings of one another. And so the point of this is to show you that in HTML, we very quickly start creating relationships to each other, right? We say, hey, this element is actually a part of this bigger thing, part of this container, right? So what's one example? Well, if I'm on, for example, if I go to the CN homepage, right? Not all the elements kind of exist by themselves in the wild. We may have a headline ticker, right, where we may feature the top 5 most important news. Well, all 5 of those lines of text, it belongs to this idea of a header container, right? And then you might have a body with videos, you might have a sports page here, you might have a politics section here. And so you can imagine with any website how very quickly we start breaking it off from kind of this monolith of a page into smaller and smaller components. And so the parent-child relationships really helps us kind of do the same thing on the HTML side, which is say that these elements belong to this bigger section, and these elements belong to this bigger section. So on the previous page, we looked at a parent and a child relationship. This is how that relationship now looks in HTML. We start off with a body tag, which essentially is just a big container to say, hey, this is where all the HTML we're going to work at is inside. And notice how the HTML, the body tag starts on line 1, and the closing body tag ends on the very last line, right? This just means that everything in between those tags belong to the body tag, or it belongs to the body, right? And in itself, that's already kind of one idea, one way in which we're drawing out this family tree, right? Is that we're saying the H1 and the unordered list, they all belong to the body tags. When we go to the body itself, water. When we go in the body itself, you'll notice that we have an H1 tag as well as a UL or an unordered list tag. And if we go into the unordered list tag, notice how we have 2 list items. One is called 1 and one is called 2. And so if we draw the family tree for this is how it will look. We start off with our body. Right? The body breaks down to 2 more elements, H1 and UL. The H1 is just a header, a piece of text, and so it ends at the text called list. On the unordered list side, we break down to 2 more items, each of which is a list item, and we see our text 1 and 2. Right? And so almost any web page that we look at is going to, the HTML for that page is going to be able to be broken out in a very tree-like structure like we see here, right? Where everything kind of feeds up, but then as we get more and more granular, we break out the sections into more and more detail. Now, because we want to show that relationship, right, that this belongs to this, if I look at the code on the left-hand side, we'll notice how everything looks kind of like the same, right? I have a div, which is another container, and someone asked earlier, but like, what's the difference between a div and a body? Typically speaking, you only have one body tag on a page. They both do the same thing, so you usually only have one body tag on a page, but the div tag you can have as many as you want. And so body just basically means, hey, this is where all the HTML on the page is going to be, and then div are the individual smaller containers for each piece of code on the page. Anywho, so we have a div, we have a div tag, then we have H3, then a p tag, then another p tag, then we close off div. If someone's asked me, hey David, what's the parent-child relationship in these blocks of code? It would take me some time to read through the code and figure out what it's trying to say. On the other hand, when I look on the right-hand side, you'll notice how it's the same exact code. The text is the exact same. The only difference now is H3, the H3 tag, as well as the 2 p tags, they've all been indented by 1 unit. 1 unit in this case could be a tab. It could be four spaces. honestly, I don't care what you use as long as you're consistent throughout your code that you're using the same type of spacing each time. In any case, when I look at the code on the right, it actually becomes a lot. And someone asked me, "What's the parent-child relationship here?" It becomes a lot easier for me to answer right away. Why? Because the H3 and the two P tags, they're all indented 1 unit relative to the div tags. And so it becomes very easy for me to kind of just visually partition out the middle 3 blocks of code from the div on line 1 and the div on the very last line. And I can say, oh, it looks like H3 tag as well as the two P tags are the child of the div tag, which is a parent. And so that's why the code on the left and the code on the right will execute the same way. Once again, we'll talk about how white spaces don't really matter in HTML in a little bit. Both lines of code will execute and run the same way. The difference is the code on the right is easier to read, especially for other human programmers, and so therefore we prefer, and it's better convention, but it's basically just at this point correct for folks to space their code in a way that reflects the parent-child relationship, right? And once again, the whole point is that the child is just indented 1 extra unit relative to the parent. All right, let me check the questions here really quick before we move on. Our div tags, parent tags, and got it. Yeah. So any tag can be a parent tag, and any tag that has an open and close tag could be a parent tag, and any tag could be a child tag, right? It's all relative, right? It's like saying like, is your uncle a parent? Well, relative to your grandmother, no, he's a child, right? But relative to your nephew, he's a parent. So it's all very relative. Same thing here. Same thing here. If I could have divs outside of divs inside other divs, so the tree gets very convoluted very, very quickly. So yeah, so it's all relative. It's not absolute. Okay. So we've talked about creating the bare elements for the tags. We've talked about how they relate to each other through the parent-child relationships. Now we're going to talk a little bit about how they relate spatially. So how they actually look on the page. And to do that, we are going to do it through talking about block and inline elements. So here on the only thing on the page so far, I made two P tags. It's once and just so you guys know, the closing and the opening tags, they come in pairs, and so whenever you see an opening tag, the next closest closing tag is paired off with that. Okay, and so here we have two P tags. They both say hello. I put them next to each other when I write the HTML. But when I render them on the page, they render on separate lines. The blue borders are just for illustrative purposes. They don't show up on a real website. But the point here is to let you know that even though the text hello is super short, P tags are what we call block elements. What are block elements? Block elements are elements that say, regardless of what I contain inside, I'm going to take at least the full width of the page, right? And so in this case, even though hello only takes up less than a quarter of that width of space on the page, the block element says, I'm going to reserve this entire width of the page for me, and I'm going to use that to show my text. So the blue border basically shows up how much space the block element takes. Every block element wants its own line on the page, and so here we see that even though I put the two HTML elements next to each other, because they're both block elements, when they get rendered, aka when Chrome or Internet Explorer, God forbid, or Firefox or anyone else tries to show these elements, they actually show up on their own lines, right? So the first P tag says I need my own line, and I'm gonna say hello. The second P tag says I need my own line, and I'm gonna say hello. And so therefore we have two lines of hello with each of them taking up their own line of space. These are block elements, and this contrasts with what we call inline elements, or elements that kind of show up inline, or as you can probably see by the image. These are elements that basically say, I'm only going to take up as much space as I need. Now, if I need to go to the next line because there's not enough space for me on this line, I will, and it will, right? That's fine. But in this case, I'm trying to show two elements. The span is another tag. Spans you can think of very much like divs. The only difference between a span and a div is that a div is a block element and a span is an inline element. And so if we look at the behavior of the inline element, basically says, I'm going to take up as much space as I need to show my content. Once I do that, I move on. And so here, when the first span tag sees your hello, when the first span tag sees a hello, it'll say, great, I'm gonna render my hello, and I'm done. The next span tag comes on and says, I need to show goodbye. It says, oh great, I can just fit it next to the hello on the same line without taking up any more space, so I will. And so even though on the HTML side, notice how I put the two elements on different lines, right? The behavior of the HTML, it's not based on how I write the HTML, it's based on what the HTML actually does, right? And the HTML in this case says, hey, whatever elements I have, I'm just going to put them on as few lines as possible, essentially. And so just to kind of drive the point home, H1 and H3, as you can imagine, the headers, they're all block elements. And so no matter what I type, no matter how much space it needs, they will always take up at least their own line. They'll always take up at least the width of the entire page. Whereas if I combine multiple spans together, then they'll just try to kind of fit as snugly as possible on the same line next to each other. Now, if I added one more span here and it didn't fit, then it would absolutely go to the next line down, right? But it does so out of a necessity and not because it's trying to reserve the spots beforehand. Yeah, sorry, go ahead, Diego. Yeah, so div tags, so it's a little bit of a nuanced thing. Div tags usually can hold just like anything, really. P tags is usually meant to hold just text. Span tags can hold text, just like how div tags can hold text, but span tags can also be used to hold other things too. So that's why I say span is more like a div by default. But yeah, if we're just shoving only text in, then a span and a div and a p tag, it's not much difference. They're all pretty much the same thing. Yep. Yep. Great question. And oh, sorry. Go ahead. How do I tell a difference? Sorry. How do I tell the difference? Or I didn't hear the first part of the question. Oh yeah, sorry. Yeah. So the unfortunate part there is there's nothing in the way the tag is written itself that will let you know. You just kind of need to know. You know that divs are block elements and so on and so forth. The kind of snarky answer that is probably more akin to the real world is you'll build a web page, you'll think it's one thing, and then when it renders, it'll render incorrectly, and then you'll realize that you were wrong and that it's probably the other thing. So when we talk about CSS, we'll talk more about like how nuanced the different ways to style things are. But yeah, I guess to more directly answer your question, there's nothing in the tags itself based on the way it's written that tells you if it's block or inline. You just kind of need to know by either beforehand or by observing the after effects. Yep. Any other questions? P tags are block text, yes. Cool. Anything else? Okay. Sorry. I already went through this part. Okay. So the last couple of things we're talking about attributes, and then we'll talk about some like kind of common mistakes and just reminders on the HTML side. So attributes you can think of as basically additional information that we can give to the tags, right? So if I have a p tag and I put a bunch of text in the middle, that's information, but it's not relevant to the tag itself, right? It's just it's like saying like, hey, I'm gonna reserve this for text. Well, whatever text I put in it's kind of like it's not related to the tag itself. The tag itself is just meant to contain text. However, there are going to be situations in which we actually want to pass data to the text or sorry to the tag itself. We can call it metadata. You might hear it call it that way too. Here we'll call it attributes. And the way for us to do that is actually to be able to pass information into the tag itself. So if we look at on the left hand side, if we look at the HTML, notice how I have the p tag I have the p tag there. But now rather than just kind of closing the tag off right away, I put a space and I put ID or class equals and I put in a string. In this case, what ID and classes are is they're just identifiers. There's things for us to tell the element apart. So why would we need to do that? Well, if I think about it, let's say I have a very complicated website with like 30 elements in it, right? Let's say I have 30 lines of text, right? So 30 p tags in this on this web page, and I want to change just one of them. I want to change the color of the text to green. Well, how would I select just that one element? Well, then what I would do is I would use the ID tag here. Basically, what ID is that an ID is a unique identifier. Think of it as almost like a social security number. On any given page, there should only be one tag with a given ID value, right? Every tag could have their own ID value, but you should never have multiple tags with the same ID value. And the reason is because when we use ID, generally speaking, it's a way for us to kind of pick out only and only that one element. The flip side of that will be the class tag. So we see it on the bottom here. What the class tag does is it allows you to group a bunch of elements together. All right. So if I say, hey, can you give me all the tags with the ID just me? I'm only going to get one response back. I'm only going to get one element back. If I say, can you give me all the elements with the class all of us? Well, class, as you can imagine, it's an organization, right? Kind of like us right now. Like class is meant to be a group. And so whenever I use a class tag, the idea is I want to group a bunch of elements together, but obviously still be distinct enough from everyone else. It's like saying, can everyone, with the social security number 1, 2, 3, 4, 5, 6, 7, 8 come to the front of the class? I should only see one person coming up to the front of the class. However, if I said, can everyone with dark hair come to the front of the class? Well, not everyone's going to come, but I would expect more than one person coming to the front of the class. And so ID and class are basically examples of metadata that we can pass, that we can use to distinguish HTML elements from one another. And you'll see how they're used tomorrow when we talk about CSS, right? But just now know that this is kind of how we set the distinction between the elements. Any questions so far? Yeah, so it's a little bit of like a chicken or egg because it's like, oh, why do it's going to be easier to explain to you why this is important once you see the use case for it. But we're not going to see that today. You can think, okay, so I'm going to move on to the next slide and then ask your question again if it doesn't quite make sense. So whereas ID and class are just ways for us to pass extra information to the tags, in this case, it's more to identify and group them. However, some tags also actually require additional information in order to function or kind of do their core job. So on the bottom now, let's take a look at our image tag. Let's take a look at our image tag again. So once again, it's a self-closing tag. And notice how now, so someone asked earlier, what does SRC mean? I think it was Katie. SRC means source. And so for any image tag, the only thing that it really needs to know is, hey, where's the image I'm trying to show? Where is it being stored at? Right? It never shows this text on the page anywhere, and there's no need to show anything else on the page besides the image itself. And so this is an example of us using SRC as an attribute. It's a way for us to pass extra information to the image tag. And what information are we passing it? In this case, we're passing it the web address of where the image is being stored, likely on a cloud server or on a hard server somewhere. And if we look above on the other, another tag that you're going to learn more about in your readings during the workshops is the A tag, or what we call the link tag, right? An A tag is basically a way for us to create a link so someone can click on this link and it'll take you to another website. There's two parts to this, right? The first part is, okay, well, what do we want the link to be called, right? In this case, I call my link visit Google, and so that's what I put in between my opening tag and my closing tag. That's one piece of information, and that's very flexible based on me. The other part of information that's not as flexible is, well, it's a link tag, right? It's a link. So where do you want this to link to? And so here we pass another piece of information called the href. It's another attribute. And what it does is here we just feed it a URL. And now whoever clicks on that link, that link's going to take him to that web page, in this case, google.com. And so the whole point of attributes is that it's just additional ways for us to pass more information to the tags. Sometimes that information is used for grouping and identifying, like with ID and classes. Sometimes it's used to provide the location where the image is being stored, like on image tags. And then sometimes it's also being used to tell, in this case, linking tags where they should be redirected to. So I don't know if that made it better or worse. I don't know who asked that previous question, if it makes it better or worse. But essentially, once again, you can think of attributes as just additional pieces of information that we may or may not want to give to the elements on the page. Did that help? A little bit? Not at all? Okay. Yeah. Tomorrow when we take a look at at CSS, I promise it will become a lot clearer because you will actually say it will actually ask you, hey, can you change the third list item to red? And you'll realize kind of how important IDs are or how important attributes are in terms of being able to select or deselect things with the elements on the page. Okay. I guess it's hard to top the question of I don't know what this is supposed to do, but are there any other questions about anything we've covered so far in terms of just any details, any nuances, any behaviors, anything like that that I can clarify before we move on to best practices and tips? Okay, so some quirks of HTML. Two of them. The first one, white space doesn't matter. What do I mean by that? We saw this already earlier today, right? But actually, no, we didn't see this. We saw the next one, so I'll clarify a little bit. What HTML will do is when HTML sees a white space, so a blank space on your page, it'll say, okay, cool, that's a white space. If on the example 2, if it sees like 10 white spaces in a row, it will say, oh, okay, I think you meant to do just one white space. And so in all three of these cases, when we get rendered the code on the page, notice how what gets rendered is the exact identical, right? So hello space world. Doesn't matter how many spaces we put in between hello and world, what HTML is going to do is going to take all that white space and it's going to truncate it and condense it into one single white space. Similarly, on the next line, if I have a p tag and I put a new line or a return or a new line after hello world, any spaces that comes before or after the text, it doesn't count. Now, there are ways to specially render a blank space in HTML, but the point here is to show that just because if you want to use white space in HTML to customize the appearance of something, you should probably figure out another way to do it because HTML does not really treat white space in HTML the same way it does when you render it on the page. And so if I wanted to show, for example, multiple white spaces between hello and world, then you need to do something very different in terms of how I want to actually show that. And we talk about it later, but just this is kind of more like a don't think the left hand side is going to pan out to the right hand side. Yeah. Hey, Teresa, do you mind going on mute really quick? Going on mute. Thanks. So white spaces don't really matter in terms of how it shows up on the page. Similarly, the way you align your code also doesn't matter, right? On this left-hand side, I put two p tags, one on top of the other. On the second example, I put them next to each other. You can probably guess they both show up the same exact way because once again, when your browser renders these elements, it doesn't do so based on the way the HTML was aligned or written. It's based on what those actual elements actually do, right? And because p tags are block tags, um, no matter how I arrange them, everything will always show up on their own line. Secondly, HTML is too forgiving. What do I mean by that? A lot of times when people write HTML will never throw an error at you. It will just render as much of the code as it can based on what you've written and do its best. That may seem like a blessing, but in reality, what it often does is a lot of times you might see your page and you might write your HTML. You might see your page and be like, huh, that's not what I thought it would look like. And that's basically a way for us, like you need to look through HTML in more detail to figure out why things aren't showing up. HTML will not just throw a blanket error the way that, for example, JavaScript might when you write improper code. And so that leads us to the next topic, which is actually one quick detour between this is that if you ever want to leave a comment on a piece of code, a comment essentially is just something for other humans to read, right? The computer basically skips over it whenever it sees a comment in any language. In HTML, the way to write a comment is to have an open caret, exclamation mark, what we call a bang, and then 2 dashes, and then you close off the comment with 2 dashes and a closed caret. And so here on my HTML, I have a hello p tag, I have a world p tag, I have a really 5 lines of comments in the middle, but what gets rendered is just the hello and the world. The computer essentially skips over all the comments. Comments usually are things that you write to leave for future programmers who are looking at your code. It could be an explanation for what something does. It could be an explanation for why something is the way it is. It could just be a warning of do not touch, right? No matter what it is, just know that comments are things that you leave that will never be read by a computer. Okay. So this takes us to the last topic we'll talk about, which is what are the common HTML mistakes. When you have an open tag, assuming it's a tag that requires a closing, please close it. Similarly, if you try to use an open quote for any string values, also close it. Right? Sounds simple, but you'd be surprised how often people forget that. Misspelling, also very common, as well as failing to indent properly. Once again, the failing to indent properly is interesting, right? Because whereas everything else will probably make your code run incorrectly, the indent properly, once again, it's a convention. It's a convention almost on the level of correct code, right? Think of writing a letter to someone and not indenting your paragraphs or not putting a space between your paragraphs, right? It's just like a convention that's at this point become like the correct way of doing things. So please make sure that you do it, especially if you're looking for a job after this. If your code is not indented properly, it's one, a big pain in the butt for whoever's looking at your code, but two, it just reflects almost at this point almost remarkable unprofessionalism. So make sure you do that. And then lastly, I'll just say a few more things here. One is write as much code as you can during the workshop. And then two is always make sure that whenever you're writing code, always make sure to run it as often as possible, just to make sure that whatever you're writing, you're aware of what's actually happening. A lot of times what I see is people write code and they assume, oh, this is going to show up exactly the way that I want it to. They keep writing, and then when they actually run it for the first time, so many things are broken, it's hard to figure out where things first started going wrong. So, write often, check often, test often, as much as you can. Okay, any questions on this content before I break us off into groups for the second part of class? Okay.